every day. Okay, so logs to exponential and exponential to logs. Okay, this is just a mini skill to learn how to solve. So you need to know this. Today we learn little mini skill. Tomorrow we learn other little tools so that we can solve. Okay, so these 2 days are like little things that we're learning so that we can solve. So if you don't learn these two, then you won't be able to solve. Is basically the essence of that. Again today, super easy. Okay, so log form, logarithmic form is this: log b a equals x. If you Google this or look on a textbook, they can use different letters there. They're not always b, a, and x. We choose these because we can write words for them. For example, b for base. A, x, and b can be any number. Okay, so they're just variables. Base, A for answer. And you'll see what I mean by that here in a second. X, I know that's not how you spell exponent. You spell it with the E, but still, think of exponent. And this might help you learn how to convert it. Okay, so we convert this to exponential. Okay. So exponential form is this. B, the base. Exponent, x for exponent, so to the exponent power equals the a, which is the answer. So that's it, that's how I said it. Okay, so box this in. That's what we use all today to convert from one to the other. Okay. Let me put some numbers on there to give you a basic example. So if you have log 2(8) equals 3. Now 100% you can just look at where does the B go, where does the A go, but then I saw somebody do this and I think it helps. I actually find myself doing this. This arrow to this from here to here. So 2 to the 3 power. And then equal 8. So like a little pattern with the arrows too. Yeah, so it works good, I think, too. Okay. Is that okay, guys, so far? Yeah? Okay. And then 2 definitions that will play a big role again today is log of x is the same as log. What base is it if it doesn't have a base? If I remember, 10. Okay, so remember, you do have to know that. Okay, if it doesn't have a base, or it's a base 10. Okay, the other one you need to know is if it's a log with the base e, which is Euler's number. 2.71. That's what e stands for. You're absolutely right. But we don't never write log of e. We write ln of x. Okay. So that's another one you have to know, so that you can switch. So these are just definitions, and they're very useful for when we're doing these problems. Okay, so let's begin. We're just going to do some examples. First, let's convert logs to exponentials. Okay, so example 1. Oh wait, no, that's exponential. Sorry. We're going from logs to exponentials. So we're going to do log 749. Okay, so I'm going to do this first one, and then you can do the next one. Okay, so here's the easy way. 7 to the 2, and then equal 49. Notice what you write has to be mathematically true. 7 squared is 49, right? That is true. If you did these out of order and by accident you wrote 7 to the 49th equals 2, that makes no sense, right? So that's obviously wrong because that's not true. That makes sense? Okay. All right, guys. I'm going to adapt to you. So as many as we need to do before you guys got it down. So try this one. Easy day, okay, easy day. If you're paying attention, which everybody is, pretty simple. So again, I think the arrows help. 2 to the 5th is 32. How many of you got that right? Set up right. Raise your hand, please. Okay. By the way, all this, I thought about taking the calculator off, but I forgot to. You don't need your calculator at all today, okay, unless it's for checking. Like here, how do you know that 2 to the 5th, you need to be able to do this, is 32. Okay, that means it's 2 times 2 times 2 times 2 times 2, 5 times. So let's do it together real quick. 2 times 2 is? 4. Times 2, 2 times 4 is? 8 times 2 times 2. That's how you do it, okay, when you don't have a calculator. You just chunk it, chunk it, chunk it. Okay, now I just want to show you the curveballs, like the weird ones. That way when you see them, you're comfortable with them. Okay, try this one before I know most of you can do it, but there's something implied, right? Yeah, it's beautiful because I see the light bulb turn. Oh yeah, that's like, I forgot. Yeah. So if you forget that, right, you're stuck. But you have to put the base, right? It has to have a base 10. Okay, so 10 to the 3rd is 1,000, which is true. 10 times 10 is 100, times 10 is 1,000. Okay. Okay, last one, just so you can see how do you do it if it's like a fraction. Okay, try that one real quick. Okay, so here it is, 4. Again, you can do the arrows. 4 to the negative 3 is 1 over 64. Which is absolutely true. Remember, because the negative power means it's unhappy there, so it wants to go to the bottom. So it's 1 over 4 to the 3. That's what that really means. Okay, negative powers are unhappy. Is that okay, guys? Everybody good? Okay, let's go the other direction. Part 2. Let's go from exponential to logs. Okay, so that's the one I was about to do. 5 squared equals 25. Okay, let me do this one and then I'll let you do the last one. Or the next one. So base of 25 equals 5. When it's an exponential, it's easy to check. Like, is 5 squared 25? Yes. So I know that's right. But this is harder to check without a calculator. Is that true or not? Well, I like to, once I do it, I double check. Oops, I messed up. 5, 25, 2. Sorry. So I like to do the little arrow, right? Like, is that that? And is that that? And it is. Okay, so once I put it in log, I double check that it's still true. Does that make sense? Okay, try this one then. Okay, so here we go. log of base 8 of 1 equals the exponent. Okay, and then just again, double check, make sure it's true. How many of you got it right though? Please be honest, sorry. Most of us. Try this one, guys. 3. It doesn't matter if they're fractions or whatever. All of this is still the base, that's still the exponent, that's still the answer. Okay. Whether it's a fraction or a number or okay, so log so good? How many of you got that one right? Good, good, good. So again, remember, it just has to match, right? 3 to the negative 4 equals. Okay, check here with the arrows to make sure you did it right. Okay, good? Okay, last part, most important part. Part 4. Oh wait, before we do that, part 3. We only do 2 or 3 problems on this. Convert if they don't tell you what it is. So like they don't tell you convert to this. You have to analyze and think about what it is so that you can convert to the other form. So for example, is this exponential or logarithmic form? It's log, right? It's log in disguise. ln is really that. So because it's log, that means you have to convert it to exponential. So the definition is very important because if not, you're stuck. Right? If you don't know how to do the definition, you don't know what the base is and stuff. So E right, just the arrows. Okay, try this one similar to that one just to make sure we got it down. Okay, so here we go. ln is really log e of 10. So e to the x equals 10. Maybe you got that one right. Okay, most everybody. Okay. Questions, guys, on that? Okay, last one of this kind. Mm-hmm. Okay, so here we go. Log of base e to the 50 equals x. So remember, you don't write log base e, you have to rewrite it as. And so if you say it as base c, you have to rewrite it as ln. Everybody okay with those?
Yes. No.
Question? No? Okay. Here's the most part 4, or yeah, 4. I think this is where you see like why, what's the point of doing this? Okay. Evaluate without calculator. Okay, without a calculator. So number 1. Okay, guys, so evaluate means what's the answer to this, okay? And it's like, I have no idea, right? Without a calculator. With a calculator, you just plug it in and push enter, and it throws the answer at you. But this is where you convert, and if you convert, it's really easy to do. I don't know how to do log, but I know how to do exponential. Like the other form's a lot easier. So I don't know the answer. I don't know what the answer is. I don't know. Okay, that's what we're trying to find. So I could put a question mark right there. So I convert 6 to the power of x equals 36. 6 to what power is 36?
No.
2, right? Yeah, I know what you meant. 6 times 6. 6 times 6 is 36. So x equals 2. Yeah, I know what you meant, because 6 times 6 is 36. Okay, so the answer to this is just 2. That's what evaluate means, okay? And that's why converting lets you be able to do that, okay? Okay, try one. You're going to be tempted to use your calculator. Don't push yourself. You can do it. Well, not necessarily. I mean, it's equal. You don't know what it's equal. So you could say it's equal. That is the question. What is it equal?
He never read it, he just accepted it.
I'll help you do it. I'll help you do it. Watch. So here we go. 2 to what power, I don't know, equals 128. Right? Log to exponential. So I honestly don't know. We just do it. Watch. So you just start multiplying. Let's do it together. What's 2 times 2?
4.
Times 2? 8 times 2? Times 2?
32.
That's 5 2s already, okay. And then 32 times 2?
64.
64 times 2? 127. And that's kind of fast. Maybe you have to do it slower, but that's how it works. Okay, so the answer is 7. Okay, no calculator. even you always have at least a blue calculator, so you could do 2 times 2 times, or double it every time. Okay, number 3. Look at my pick right. These are a little more challenging, so we're going to do a few more examples. Try that one. You look at that and you're like, I have no idea how to do that, but just take it slow. What's the base? Convert it.
It's gotta be a negative.
It's always neat to me, guys, when you come in, because like if I would have gave you this at the beginning of class, no idea, right? We have no idea how to do that. And in a little bit you learn, right? So base 10, if you have no base 10. I don't know what the answer to this is, right? So 10 to what power is 1 over 100. Well, that's confusing because I have no idea. But 10 to what power is a regular 100? 2, right? 10 times 10 is 100. But it's below, so negative 2. The negative brings it down, brings the 100 down. Okay? So the answer to this is negative 2. Y'all following with me why it's negative 2? Because yeah, it brings it down. Right? Okay, that's number 4. Okay, this one's a little harder. 16. Okay, so I want to do this one with you because I want to explain something. So I don't know what that is. So 16 to a certain power is 2. Okay, well guys, I want you to watch please, because this, if not you're going to get stuck on this without a calculator. Calculator is super easy, but without a calculator. So you're going backwards, you're not making the number big, you're making the number small, right? It's easy for us to make numbers big, it's harder to shrink them down. So just do it backwards. 2 to what power gives you the 16? Well, let's do it again. 2 times 2 times 2 times 2. That's 4 2s. Okay. So to go in this direction, you have to explode it by a power of 4. So if you want to go backwards, you shrink it by the opposite of 4. Try it on your calculator just so you can double check. Okay. 2 to the power of a fourth. You do it backwards. 2 to the fourth is 16. So you do it backwards. Work? Huh? It's good? It makes sense how to do it backwards? Yes? Okay. Once you see it once, you know how to do it. Okay, last one. This one's easier. But just so you have one more practice of those. Log base 3 of 1 over 27. And you can put X, you can put question mark, you can put a whole, whatever. Okay. 3 to what power is 1 over 27? Well, 3 to the what power is regular 27? 3, right? 3 times 3 is 9. 9 times 3 is 27. So 3 3s, right? But it's down below. So negative 3. The negative brings it down. Does that make sense?
Yes.
Yes? Okay. Okay, guys, listen carefully, okay? Because I'm going to make another, over the break, I thought of another idea. Let me stop the video because this does not pertain to that.